Hello everybody, welcome to a new exciting series on the application Euler formula. So today I would like to introduce the Euler formula and work through several problems. And eventually we'll build up and we can even conquer very hard math concept. But it is very easy in a complex number way. So let's go ahead and get started. So what's the Euler formula? Okay. What is the Euler formula? Well, the Euler formula say e to power e of x, I is the imaginary, equal to I times sine of x plus cosine of x. Okay? So today, we will, in the first video, we'll use this formula I bracket in red to derive the formula for the addition and of cosine and sine. So what I mean is we're going to use the red formula to derive the formula for cosine a plus b and sine a plus b. Okay, this is what we're going to do today. This idea is being inspired again by 3 Blue 1 Brown. I have the link of his video below, so you guys can check it out. So, inspired by 3 Blue 1 Brown. He's great. What's the video name? It's called Complex Number Fundamental. It's on YouTube. You can see it on YouTube, and it start, I think, minute 54:33. Okay, without further saying, let's go ahead. So how do you get the cosine side? You look at the formula at first, and you see there's a cosine of x, right? So here they ask us for cosine of a and cosine of a plus b. So let's go ahead and make cosine of a and cosine of b appear. Okay, so using Euler formula, using Euler's formula, you get e to power I times a equal I sine of a plus cosine of a. E to power I times b equal I sine b plus cosine of b. Okay, wonderful. So now what I'm going to do for the addition for a plus b, I want to make a plus b appear, right? So let me want to make a plus b appear. So how do I do that? I'm going to times e to power a to e to power ib. Okay, so you see in a second. So from above, if you times the two together, you get e to power ia times e to power ib equal to I sine a plus cosine of a times I sine b plus cosine of b. Okay, wonderful. So now what you're going to do is, remember, e to power x times e to power y is e to power x plus y. So it's e to aa plus ib equal to, I can start phoning this out. So if you phone this out, you get I square sine a sine b plus I times cosine of a times sine b plus I times sine of a times cosine of b plus cosine of a times cosine of b. Okay, so the next step is I can factor out the I here, so it's just a plus b. And if you recall the definition of imaginary number, I square is -1. So this is just negative sine A, sine B, plus I cosine of A, sine B, plus I sine of A, cosine of B, plus cosine of A, cosine of B. Okay, the next step I'm gonna do is I will arrange I will group them together. I will group the imaginary term together and the complex term together. So e to the I A plus B equal to I times cosine of A sine B plus sine of A cosine of B plus cos A cosine B minus sine A times sine of B. Okay, so after that, what I noticed is this. So you recall the definition, right? The definition of the formula, e to the power of I times something is I times sine of that thing plus cosine of that thing, right? So in this case, we have this expression, e to the power of I times A plus B. So I can replace that as I sine A plus B plus cosine of A plus B equal to I times cosine of A times sine of B plus sine of A cosine of B plus cosine of A cosine of B minus sine of A sine of B. Right? So if you want the left hand side equal to the right hand side, in order for the left hand side to be equal to right hand side, RHS, what's gonna happen is the real component will have to be equal and the imaginary component have to be equal. Okay, so with that being said, what's the real component of the left hand side? This is the real component of the left hand side. Okay, and this is the real component of the right hand side. Okay, and what's the imaginary component? The imaginary component is this of the left hand side. Imaginary component is this one in blue of the right hand side. Because if you recall, like you have A plus BI equals C plus DI. Okay, so you have A equals C and B equal D. Okay, Okay, so A and C in this case is the real component. C, B and D in this case is the imaginary component. So with that being said, if you equate both sides, you get sine of A plus B equal cosine, oh my bad, yep, it's correct, cosine of A sine of B plus sine of A cosine of B. Similarly, cosine of A plus B equal to cosine of A times cosine of B minus sine of A sine of B. Okay, so that is exactly the expression we want to arrive at. Okay, you see, very, very beautiful, right? So yeah, that's it for this video. I really appreciate everyone's attention. In the next video, we'll derive the subtraction formula. Okay, I'll see you soon.